9.2, we're going to actually go through the process of doing a hypothesis test or inference. Let's go. So we are going to have to check conditions, same as we have to do for confidence intervals, which is really our first bit of inference that we do. Now we're also going to perform significance tests or a hypothesis test, and we'll look at the power of it, which is interesting, and again talk about type 1 errors related to the power of the test. So when we do this, and that's why I brought up the free throw thing previously, because we refer back to it. So he thought he was an 80% free throw shooter. He took 50 shots. He made 32. So he's really a 64% free throw shooter. We're going to find out, does this provide convincing evidence against his claim? So we're going to have to perform a hypothesis test or a significance test with a null hypothesis that the proportion is actually 80, an alternative hypothesis that is indeed less than 80 the proportion. So we got P in our parameter, B, is the actual proportion that he throws in the long run. So we have already introduced these conditions that need to be met. And they also need to be met when we are going to do any sort of hypothesis test or a significance test. They're the same. Okay? You must check assumptions. All right. All right, so we look at a. So we're going to actually carry out. We're actually going to look at the probability of this occurring using standard normal probability. So here we go. All right, this is how we actually get our test statistic. All right. So we're going to have some sample data, and we're going to find the probability of that data occurring. So, amazingly enough, right? You've seen this exact formula almost all, right? Except for we took a brief break and we're looking at different probabilities.
So we did try to do.
Well, we're always going to do we're going to get our test statistic by doing our statistic minus our parameter. We're going to divide by the standard deviation of the statistic. So that's how we acquire our test statistic. Probably would have been cool to put that same in the video.
Oh, we're seniors. They're growing.
All right, so we're going to carry this thing out. Just what I was saying, right? Our test statistic is going to say how far away from our, whatever statistic we got is from our null hypothesis, right? Which is a parameter value, right? And based on that, we can find a probability. In this case, we have a z-value, we got a standardized value, a z-score rather, right, of negative 2.3. What is the probability that we have a value as extreme or more, right, in the lower end of things than that? It's pretty small. Almost positive. We're going to find out what that is right here. That value is extremely small. 0.0023. So in this case, for our free throw shooter, who says he shoots 80%, but winds up shooting 64%, we want to know, is it possible for a value as extreme as that to occur by chance? No, because we get such a low p-value. In which case, we are going to reject the null hypothesis, which was that his proportion of mates on free throws is 0.8, right? So we have convincing evidence that his free throw percentage is actually much less than 0.8. So he's not an 80% free throw shooter, and we do have evidence that he's actually he shoots less than 80%. Cool. So now we're going to start getting into different types of tests. So what we just performed was a one sample z-test for a proportion. So if we're given a proportion, this is the one we're going to go to. Significant tests, this four-part process. What I really prefer is this, and I'm going to change it because, I mean, if you like to do the state plan, do you conclude thing? That's fine. But I feel like this gives me like an awesome roadmap. So now we're going to go through, and I'm going to finish phantoms for you, okay? So, P stands for parameter. So what do you want to do? You want to state the parameter of interest. Stater? So we'll state the parameter of interest. H. You want to state your hypotheses. Hypotheses, right? Your null hypothesis and your alternative hypothesis. A, assumptions. Check them, right? Check your assumptions. 10% condition. In this case, you need to check the 10% condition. You need to test for normality. And the data needs to come from a simple random sample. Your conditions or assumptions, right? SRS, normality, and name the test. So in this case, we would name one proportion z-test, right? T, get a test statistic. Right, so we'll get a test statistic, we'll calculate that. O, obtain a p-value. M, make a conclusion. In other words, reject or fail to reject the null hypothesis. Reject or fail to reject. And the last thing you need to do is state your answer in context. Every single time I perform a significance test, I will use this process. I will go through phantoms. Every single time.
At 5:30?
So we got phantoms as our method of going through the process of carrying out a significance test. And this kind of talks about each one of those elements, right? When conditions are met, that refers to A in phantoms. And then, if that's true, we're able to calculate, we have a mean, we have a standard deviation. And using that standard deviation and mean, we can get a z-score, right? So we can get a probability using our normal distribution. And then we'll get a p-value using it. So, that's that. This is the formula that you'll use when you're dealing with a proportion, a one-sample z-test for a proportion.
So he's like, that's a crazy.
So we will get a test statistic, and then from that test statistic we will be able to get a probability, or a p-value. So it can be one-tailed, that is the graph on the far left, or in the middle, right? Those are one-tailed, where you're trying to find if your parameter is greater than your statistic. And then in the middle, where your parameter is less than your statistic. And then on the right, we have a two-tailed probability. And that's to say that it is not, that your parameter is not equal to your statistic. In which case, you'll have to find both the areas of those shaded regions and express those as a probability. That probability is your p-value. All right, so you can find variations of each of these formulas on your formula sheet. So, essentially, the framework of it is your statistic minus your parameter. So you'll have whatever value you're testing against. Over here is your statistic. Your parameter is going to be the value of your null hypothesis, right? Standard deviation of your statistic, you're going to look down here to statistics and standard deviation of statistics and decide which one to use. Are you going to use standard deviation of your sample mean or of your proportion in this case, right? We're going to use proportion, so that's all of that, right? And the p that you're going to use in this case is going to be the value of your null hypothesis. All right. Let's move on. I'm sorry. All right. For a two-sided test, I pretty much broke this down. Right. So I'll have to find both values. Let's find the value greater and the value below. The confidence interval gives you more information because it tells you about where the mean of your, or the mean or the proportion, the actual mean or the actual proportion of your population is, right? And really the idea is that a 95% confidence interval is almost like the opposite of having a two-tailed test with an alpha level of 0.05. I think there's a good picture of it. It's not a picture. It's just blurry. The two things are connected. So we're talking about both of them being happens, right? You get the probability that some value is, so with a significance test, I should say, you get the probability of a value being outside of the desired range, right? With a confidence interval, we're actually saying with a level of confidence that our mean is contained in some values. So they're very closely linked. Power of the text. So again, type 2 errors when it fails to reject the null hypothesis, when the null hypothesis is really false. When we're talking about power, it's just the probability that we'll reject our null hypothesis when it's true. And we can calculate the power fairly easily. We'll get a formula for that on the next page, and a kind of a nice picture of what power is. All right, so this picture is a fairly good representation of what's going on with the power of the text. So this potato chip producer wonders whether a significance test against, so they think the proportion is 0.08, right? And their alternative is that it's greater than 0.08. They think sample of 500 data. And they're looking for blemished potatoes. So the proportion of blemished potatoes. So we're wondering if this test has the power to detect a shipment with 11% blemished potatoes. So would we fail to reject that the proportion is 0.8 if the actual proportion was 0.11, all right? So that's the power. So it turns out that if you were to actually calculate an area there, right, or find some sort of probability, you would find that the probability that one is that we have a the probability of a blemished potato, of the proportion of blemished potatoes being greater than 0.08 is actually 0.75. So what you're saying is 75% of the time you're actually going to wind up correctly rejecting the shipment, right? That is to say, you'll create a type 2 error 0.2483% of the time. When you get the formula, it's much nicer. And that's right. So, again, when you're doing a significance test, you're looking for the probability that you really would love to reject the null hypothesis, right? So I think a better way of saying that. So we can look at the probability of making type 2 error. We're going to call that beta. And in order to calculate our power, we'll just go 1 minus v. And we'll do some examples of that so that it's a little more evident, it'll be a little more concrete with some examples. So that finishes up the kind of overview of 9.2. We're going to get into some specific questions and actually practice some inference over the next 2 days. And then we'll get into 9.3. And we'll do some inference. The cool thing is that once you've worked a lot of problems from 9.2, all we do in 9.3 is change from looking at a population proportion to a population mean. So the process is the same. You just use some different equations. So once we get the process, things go fairly smoothly.